let's go over the proof of Pythagorean theorem by this guy named Bhaskara Acharya from India. Back in 1114 he lived to 1185. So these two pictures and one word, behold. This is the only things to prove that a squared plus b squared equals c squared. So how does that happen? These two, well, actually these two figures comes from the same size of the paper. So, you know, if you just rearrange this, you get the same thing, and this comes from the same origami paper. So it should be, so that the area of these two are exactly the same. So let's put that back. And how does this actually prove that, right? Let's see. So let's call this, let's just take a look at this guy first. And let's see, this is A, oh, this is not good. This side, short side of the triangle, let's call that A inches or A whatever. And the length of this longer leg is, let's say, B. And then the longer side, the hypotenuse, let's say C, right? These four triangles are congruent, by the way. So let's name that A, B, C, and then A, B, C, and then A, B, and C. Okay, so let's put that back. So let's think about this guy. What is this? This guy, as you see, the length of this is a square, so length of this is B minus A. So this is B minus A and B minus A. Therefore, the area of this square is B minus A squared, right? So this is, the area of this is B minus A squared. So we can use distributive property, B times that guy minus A times that guy, which inside we have B minus A and B minus A. So we should have B squared minus BA minus AB plus A squared. So it is, what's the area of this? B squared minus 2AB plus A squared. Now let's take a look at this triangle. What's the area of this guy? Well, as you know, area of the triangle is A times B divided by 2, right? And then we have 4 of them here, right? We have 4 of them. So we're going to multiply this guy by 4. End up being 2AB. So this is the area of that, and this is the area of 4 triangles, and this is the area of a square. But we gotta add these 2 expression to find out the area of this entire things for this guy. This guy, what's the area of this guy, right? We gotta add this guy, which is this guy, plus these guys, which is this guy. So let's add these two. B squared minus 2AB plus A squared plus 2AB, right? These are the common factor. These are the, what's the name of it? Like terms, yeah. So these are gone because this is gonna add to 0. So what's left is B squared plus A squared. So the area of these green paper added all together is B squared plus A squared. And let's look at this. This is exactly the same I claimed, even though regardless of my drawing and cutting skills, I claimed that this orange papers are exactly the same as these guys. So we said this hypotenuse is C, so it's C, and from here to here is C. So the area of this is, since this is a square, it's going to be C times C, which is C squared, right? And as we have as we read, as we said at the beginning, these two papers are congruent. Therefore, it should have the same area. So that's why a squared plus b squared equals c squared.